Hey everybody, this is Mr. Beckstrom, and today I wanted to take a look at a problem from section 7.4. This is similar to number 9, and it says multiply the following quotient here by this new quotient here. And basically what they're trying to do is they're trying to give you a tool here by multiplying by the conjugate here. The conjugate is if you have a value plus or minus a value, you can multiply it by the same values. You just use the opposite sign in the middle here. For example, this is a plus, so you do the same term, but you just put a minus in the middle instead, and that will often give you identities that we can use. But if you do this on the bottom, you have to do the same thing on the top, so we don't actually change the values of our variables. So they want us to do this multiplication here, and then they want us to simplify. This is a pretty involved problem, a little bit more than it looks, so bear with me here. So first of all, let's go ahead and do this multiplication. Now, whether or not you want to actually distribute this or leave it alone, if you don't know, a good rule of thumb is just leave it alone until you know you have to distribute it. So we're going to just kind of leave it in non-distributed form at first. So I'm going to write this out, and so it's going to be horrible handwriting. My bad. All right, so we'll just leave the top like this. Oh, where did that come from? 1 minus cosecant of theta on the top, and then on the bottom, when we multiply something by its conjugate, often we're going to get the difference of squares. And when you have like an a plus b times an a minus b, you get that nice difference of squares product where you get a squared minus b squared. So we're going to get the first thing squared, so that's 1 squared, which is just 1, minus the second thing squared. So cosecant of theta times cosecant of theta is just cosecant squared of theta. So this will just be 1 minus cosecant squared of theta. All right. Now they want us to simplify this as much as possible. So when we see a 1 minus one of our trig functions, like we said in the previous video, that should automatically trigger our, oh my gosh, we should be looking for one of the Pythagorean identities for any of those trig functions. So if you know those identities or you have them written down, great, just go to them. If you don't, you just really have to know the first one. So I'm going to write down my first one here. So sine squared of theta plus cosine, this is the easy one to remember, cosine squared of theta is equal to 1. Now, this has a cosecant squared of theta in it, which is a 1 over sine squared of theta. So in order to get a cosecant squared of theta, I need to divide this one by a sine squared of theta. So I'm going to go ahead and divide everything by sine squared of theta to get my new one. So sine squared of theta divided by sine squared of theta is 1, plus cosine squared of theta divided by sine squared of theta is cotangent squared of theta. Cotangent squared of theta, and 1 divided by sine squared of theta is cosecant squared of theta. Cosecant squared of theta. So that's one of the other Pythagorean identities, which you can either once again have it written down, or you can just derive it from our main Pythagorean identity there, just dividing everything by sine squared of theta. So this is the one I'm going to use, and I need to get a 1 minus cosecant squared of theta out of there in order to use it. I don't have that. So how do I get that? Well, I have to bring that cosecant squared of theta over to that side. So I have to subtract it. So that's going to be 1 minus cosecant squared of theta. Subtract it from both sides. But then I have to subtract the cotangent squared of theta from both sides to bring it over to that side. So that's going to be equal to negative cotangent squared of theta. So in order to get this term or set of terms by themselves, that is going to be equal to this right here. So kind of do that like that. All right, so I can replace this here with negative cotangent squared of theta. Make sure you have that negative in there or you will not get the problem, right? So let's go ahead and do that. So now I'm going to have cosine of theta times 1 minus cosecant of theta, and I'm going to save myself a step here, and I'm going to go ahead and write this. I'll go ahead and do this like this: 1 over negative cotangent squared of theta. All right, now the next thing I want to do is they really want this simplified as much as possible. This probably would have been fine if I was running a test. However, I actually checked in the system and they would not take this. So they want this simplified even farther, and that's fine because really there's a cosine factor on the top and there's a cosine factor on the bottom, and they're being pretty nitpicky on this problem. So this is really what they want you to do with this. Remember, cotangent is cosine over sine, and cotangent squared of theta is cosine squared of theta over sine squared of theta. And don't forget that we can multiply by the reciprocal of the denominator when we have fractions over fractions. So I'm going to really write this as, I'm going to pull the negative out front, and I'm going to write this as the cosine of theta times, so I just have one negative, so I'll put it right out front of the whole fraction, times 1 minus cosecant of theta. And instead of dividing by this, what's really a fraction using the reciprocal identities and stuff, I'm going to multiply by the reciprocal of that, right? Instead of cosine squared of theta over sine squared of theta, I'm going to multiply that by sine squared of theta over cosine squared of theta. So let's multiply that by sine squared of theta. So sine, and in fact, I'm going to even separate it even more. Let's separate this just so we make sure. So I'm going to multiply it by sine squared of theta, which is just sine of theta times sine of theta, right? And then I'm going to put my cosine squared of thetas, which are on the bottom. I'm going to write those as 1 over cosine of thetas. 1 over cosine of thetas. And I'll show you why I'm going to do that in a second. 1 over cosine of thetas. And really, all of this together here, all of this together is just sine squared of theta divided by cosine squared of theta, right? It's just the reciprocal of this cotangent squared of theta. I'm just writing it like this so we can go ahead and see if anything we can cancel out and then condense it into one nice, neatly packaged identity. All right, so this cosine of theta here can cancel out with one of these cosine of thetas on the bottom over there, so that's why I did it. And nothing else is going to cancel out. So what I'm going to be left with here is a negative. I have a sine squared of theta, so I'll condense that into there's two of them, so I have sine squared of theta. I have 1 over cosine of theta on the bottom over here, so that's going to become, using the reciprocal identity, that's just going to become a secant of theta, right? 1 over cosine of theta is a secant of theta. And the only thing I have left is this, 1 minus cosecant of theta, cosecant of theta, and that is as far as we can get this down, and that's actually what my math lab is looking for right there. So a lot of work, a lot of knowing what these identities are. I hope this helped a little bit. And if you have any questions, please let me know in the forums or email. And good luck on the test, and we'll see you soon. Thanks.